I think after Dr. Grand sent me his biography, I realized maybe why Jason asked me to do this job today. He sent me his biography, and to be honest, there was some words and some degrees and things in there that I couldn't even pronounce. So with that said, I'll do my best to introduce Dr. Grand. Dr. Francois-Xavier Grand is a graduate of Toulouse Veterinary School. He has authored and co-authored several scientific publications. And Dr. Grand is a diplomat of the American College of Therogenealogy. Did I get that right, Dr. Grand? Very good. Dr. Grand is certified by the Canadian Embryo Transfer Association and is one of the 8 directors on that board. Dr. Grand was hired in 2011 by Boviteq as a specialist in animal reproduction. So with that said, it's my pleasure to introduce Dr. Grand, and he can go into more of the scientific stuff that he does on a day-to-day basis.
Thank you very much for the introduction, and thank you very much for inviting me to speak today, Jason. I will present more the donor's point of view, and we have also recipients heard, only Holstein recipients, and so some are open, some are also pregnant, because we also offer a live calf program. We have several research laboratories. The main one is here at the CIAQ. This is this branch of the star here. We have research labs, and we have our sex semen lab there. So what our mission at Boviteq is to contribute to the development of the bovine industry, to improve its performance and profitability through the development of biotechnologies in reproduction and genomics. We are using several strategies, but we are using mainly 2 assisted reproductive technologies, conventional embryo flush, of course, and in vitro fertilization. We also offer embryo technologies, and the choices of these techniques and of these strategies really depends on your objectives. And what is really important for us is you to define realistic objectives with your donors. For example, if your goal is to produce female embryos, and if we look over a 60-day period on average, if you're using conventional flush, you will be able to flush the donor once. Here I present the data of the Canadian averages, so the data from the Canadian Embryo Transfer Association, and so we'll get an average 6.4 transferable viable embryos. With 50% males, 50% females, you will have 3.2 female embryos. You will get 2 pregnancies, 30 days, also at 6 days, and so that's what you will get with conventional flush. Now, if you're using in vitro, so IVF, in vitro fecundation, the semen, if you're using non-sex semen, what we call conventional semen, you will be able, over 6 days, to do 4 cycles of IVF. We can do IVF every 2 weeks. The oocytes, what we call the oocytes, and I will mention that several times in this presentation, this is the egg contained in the follicle. So the follicles are on the ovaries, and you have to imagine the follicles like a grape, and the seed would be the egg that is, and the follicle is like a ball of liquid. The goal of the first step of the IVF will be to collect these eggs. So that's what we call the oocytes. So with 4 cycles of IVF, you will get on average 38.8 oocytes, which will give on average 31.3 embryos. Another 50-50 will be 10 female embryos, which will give on average 5.8 embryos, with on average so this 57% pregnancy rate, and at 60 days we have a 52% pregnancy rate, so 5.3 females. Now with IVF, what is really interesting is to be able to use sex semen, and so with sex semen it will be the same as non-sex. You will be able to have 4 cycles of IVF over 60 days. We collect the same amount of oocytes on average. The number of viable embryos will be around 16.7. Why? Because with sex semen there is more variability with the bulls. It means that some bulls that work very well with conventional semen will also work very well with sex semen, but some other they will be harder to work with lower results. Sometimes we can adjust the protocol of preparation of sex semen, and some other time they just don't work with sex semen in IVF. I will have the same comment as Brian earlier with young bulls. Some young bulls will work very well with flush, but with IVF won't work as well. And if you try them a few months later, then they will start working well. And so I have the same comment. The young bulls are not as well equipped as the old guys. So, keep going. Number of females embryos will be the same, and you will get at 30 days 9.2 pregnancies, and at 60 days around 8 pregnancies. So, if we calculate, it's 5 more time females embryo with sex semen with IVF than with conventional flush. I did not present the data of conventional flush with sex semen because on average it doesn't work as well as with conventional semen, I mean for conventional flush. We will get embryos, but on average not as many. Then we have to adapt our strategies based on the donors. And here, just to show you an example, I put the results of 3 different donors, and on these 3 different donors, we have been doing 3 IVF rounds, 2 weeks apart, and then a flush. The first donor, first IVF, we got 25 oocytes and 15 viable embryos. The second IVF cycle, 22 oocytes, 16 viable embryos. Third one, 34 oocytes, 18 viable embryos. And these kind of donors, usually the breeders are not interested to flush them because they are so productive with IVF, then they won't produce as many embryos with conventional flush. So they are rarely flushed. The donor 2, not such a big response. 15 oocytes, 7 viable embryos, and it's pretty much the same with IVF2 and IVF3. Usually between IVF1 and IVF3, we show a slight increase in the number of viable embryos, and it's quite constant with all donors, and it's probably when they start to enter our schedule, and they are under our conditions at Boviteq. There is no magic, but there is this effect that it improves a little bit. And then this donor, this second donor, if we flush her, we'll get about 12 viable embryos. The donor 3, lower potential with 7 oocytes. First time, 2 viable embryos, 5 oocytes second time, 3 viable embryos, and the last time, but 3 oocytes, 4 viable embryos, and we flush her, we'll get between 5 and 7 viable embryos. So what I will show you with this slide is you can see that the responses are quite constant along the cycle. So it's very repeatable from one cycle to another, and I will show you later it's related to the number of follicles that are available for superovulation, and these numbers are very constant for the same cow. Then the other thing is the other donors do not have the same potential. I mean, from a reproductive point of view, I'm not talking about the genomic merits and all that stuff, because in some donors, even if you produce 2 or 3 embryos, particularly in young donors, for example, they can be very valuable, and it is worth to do them. But it's up to you, and you have to decide the strategies you would like to use. So, concerning the donor's potential, like I said, it's very related to the follicular population. What we call the follicular population, it's here this is an ultrasound picture of an ovary. It's very magnified, but what we call the follicular population, this is the number of very small follicles, I mean between 1 and 3 millimeters, that are available for the superovulation. So this is the follicle that will develop, and then we will be able to collect the oocytes from these follicles. So if from the start the donor does not have lots of follicles, we will be able to propose some strategy to improve a little bit, but she will never have very large follicular population. So that's one thing to consider. So this follicular population are in the same animal. They are very constant from one cycle to another, from one lactation to another, and all along the life of the donor. At Boviteq, we are working on strategies to quantify this follicular population. The ultrasound, for that you need a very powerful ultrasound. We have them. It gives us a good idea, but we are also working on a blood test that we could use, I mean, without having the donor at Boviteq, and to be able to screen a little bit these donors. So now, how does it work when a donor is sent to Boviteq? Usually, before admission, we talk on the phone quite a lot because there is not that many information available in the field, and it's nice for us to be able to determine the strategies with you. So the age of the donor from 7 to 10 months old, or pregnant donors, we will only be able to do IVF with them. Then from 11 months to 18 years old, we can do IVF or flush, or a combination of both techniques. I indicated here 18 years old. In this type of donors, we don't have a lot, and it's usually not Holstein because of all the genomics advancements. It's rarely worth to do them. but in these donors, all donors will only be doing IVF, because the uterine condition is usually not very good. So then the individual history of the donor is really important. And the last calving, we need them to be at least 70 days after the calving, and I would say even further than that if you can, because of the beginning of the lactation there is this period of negative energy balance, and it really affects the quality of the oocytes. You have to keep in mind that the oocytes from the follicle that we are going to collect has started its development 60 days earlier. So it means that after 70 days after the calving, we are just after this 60 days period I was talking about, and it can be very detrimental for the oocytes. For the same reason, we don't want them to have been sick recently, because if she has not been eating for several days, or because of the fever and all those things, it will affect the quality of the oocytes also. Then her reproductive history. The donors with fertility problems are not the best donors. It doesn't mean that we won't be able to get embryos from them, but they are, most of the time, they won't be responding as well. And especially these repeat breeder cows, they are sometimes tough to manage and to work with. Then the flushing history is really important because, like I said, the response to superovulation is very repeatable from one superovulation to another, and it will give us an idea about the potential of the donor. Then, some information about the health history, about the health status for, especially for leukosis and for IVR, because at Boviteq we have to keep our sanitary status okay for all the export work. Then admission, how does it work? So the cow arrives, she will be in a controlled environment with lots of biosecurity measures, like I said, to keep our export status, and with a controlled nutrition. There is no magic in it, but there is absolutely no deficiency, and we are working with a nutritionist. He's reassessing every month and on a regular basis all the food, and he's giving us advice on some special donors. We will do a daily veterinary follow-up, and if for a medical problem the cow needs a special investigation, the vet school is next door, so we can send them there. And of course, we are 5 veterinarians working there, and we are able to do a repro follow-up as often as needed. So the superovulation step is really important. This is the beginning of both of our technologies, for both IVF and conventional flush, and the concept and the principle behind that is that good eggs make good embryos. So we want them to put our donors in the best condition for that. We have started the superovulation at a very precise moment of the cycle with dominant follicles removal. All along the superovulation, we are following the development of the follicles, and for conventional flush, it can be interesting. For example, can allow us to choose a different bull depending on the response, and not to waste a very expensive dose when the donor is not responding. And it gives us also lots of information that we can use to adapt the next superovulation program that we will do on this donor. Then we are able to repeat the superovulation, so for IVF every 2 weeks. And for conventional flush, we have been working a lot on that, and there are lots of donors. I presented before over a 6-day period, 1 flush, but now there are lots of donors. We can do 35 days between each flush, so can be interesting too. The principle of both reproductive technologies, with flush, so we superovulate the donor, she will come in heat, she will be inseminated, and we will collect the embryos 7 days after. With IVF, it's a little bit different because we will bypass a few steps of that. So we will superovulate them as well, but we won't let them come in heat. Before that, we will collect the oocytes. It's called ovum pickup, or OPU, in the rest of the presentation. Then there will be a maturation phase of these oocytes, which is in the cow a little bit like the maturation they have between the heat. Then the oocytes are fertilized in the lab, the embryo, and then, so it gives embryo that will develop, and these embryos are cultured for 7 days. What can we do with these embryos? With conventional flush, we can split the fresh embryo. We can take a biopsy. Taking a biopsy, I will go in further details for the technique, but the embryo is like a pie, and taking a biopsy is taking a piece of this pie to do further analysis, like sexing, genomics, red factor testing, and so of course we can freeze this embryo. Then with IVF embryo, we can also transfer them. We can freeze them, which is a new thing. I will go back to that later. We can take also biopsy of these embryos for sexing, genomics, red factor, and currently we are working on freezing these biopsied embryos, but it's still on research. So what's new with IVF, Boviteq? And we very often have the question that all the old IVF. So what happens in the uterus? So the first in the oviduct, which is the tube between the ovary and the uterus, the embryo starts to develop. Then it goes in the uterus, it enters the uterus at 5 or 5.5 days after, and it will continue to develop in the uterus. With IVF, all those steps are happening in the lab, and the old protocol gave embryos like that. Now we have a new protocol with different components, and that gives different embryos. You can see the aspect on the picture, and it's looking pretty much the same as the conventional embryo from the uterus, and with better results about pregnancy rates, calving rates, survival rates. Sorry. Another new thing with IVF embryos is being able to freeze them, because for a long time when IVF started in the 80s, the IVF could not be frozen. So we have developed a protocol for that. We have been tested it at Boviteq first, and at day 60 we got 65% of pregnancy. Then we have been tested it on client farms, And of 121 embryo, we get 64 embryos, 64% pregnancy rate at day 60. And this is a very simple thawing protocol, so works for direct transfer as well, the same protocol as conventional embryo, so every embryo transfer vet can use it in the field. This frozen embryo can also be exported to European Union and to the US. So now the genomics analysis that we are able to do, I won't be going as far as all the breeding strategies like Brian went, but just from a technical point of view, what the regular situation, the current situation is in most of cases. So we are breeding elite animals, we are collecting the embryos, and then we are transferring these embryos. It gives pregnancies, and then we are genotyping the calves to keep the best subjects. But it costs lots of money to keep all these recipients during the pregnancy, and then after these calves, before they are tested. And so we can offer another strategy. We can do the same, breed an animal by IVF or conventional flash, having these embryos, take a biopsy of this embryo and genotyping the embryos, and then only select and transfer the most promising embryos. The technique of the biopsy is quite difficult, but we have very well-trained technicians at Boviteq that are performing very well. But just to explain you, so here, this is the machine. Here there is a knife here that we use to cut the embryo. Here you have the intact embryos, and here you have the cut embryo, the biopsied embryo, with the biopsy here, and here the rest of the embryo. So from this sample, we are able to do all the genomic analysis, and it's quite more challenging than just with hair, because with hair you've got lots of genetic material, but here you only have this about 12 cells. So there is extra steps that we developed to get more genetic material from that, and then the genomic technique that we developed, and that gives us currently at least 99% of accuracy between the embryo and the calves tested when born. We tested them experimentally. So with genomics, parentage is also possible. It's part of the technique, by the way. So in some flushes, sometimes some breeder ask to use several bulls, and to commercialize them, you need to know the sire most of the time. And here it's the result. So this is the same flush here, and here this is each embryo with its genomic value here, and you can see, so in blue there is the sire 1, and in red the sire 2, same thing for the second flush. Then another thing important to consider, and to justify genomics, within the same flush you can have lots of variation between the genomic values of the embryos. For example, here you have very low, in the same flush, here you have embryos with very low value and some other very high. In some other flush, in some other donors too, the value can be quite even. So it really depends on the donor and on the cross, the viability you will get. So that's it. Then I will talk a little bit about a new strategy that we are developing, This is a satellite OPU site. The principle is that the donor will be collected at the satellite OPU site. The oocytes are going to be sent at Boviteq. Then at Boviteq, we will do all the IVF work, and we will send back the fresh embryos to be transferred at the breeder's farm, and we can also freeze some other embryos at Boviteq at the same time. It's quite challenging, and it's quite challenging because we want to keep the same high quality standards in all our procedures, and for that it means with the vet having good aspiration equipment, good technique, good donor preparation. Just to go back here, we have to send the oocytes. Usually the oocytes stay at Boviteq, so we had to develop a new maturation medium to be able to fend these oocytes, because the oocytes are very fragile, and it's much more complicated to ship oocytes than embryos. The embryos will tolerate some variation in temperatures, in media, and things like that, but the oocytes will die if there is any variation. So we had to do that. We have tested that, and it works very well. We have tested that in the lab, in the field also. And then, well, to send back the fresh embryos, we were already doing that, so there was no problem. But here, the shipping conditions, like I said, are very important, especially when there are snowstorms like this morning, and the flight are delayed or things like that. It can be quite challenging too. So at the end, what is really important with this project is excellent communication. It will develop in 2013, and we will keep you updated about the new steps. Then our LifeCAF program. That's a new service that we have been offering for 3 months now. What is really important is pregnant recipients management, and sometimes some breeders forget about that, but there are so many scientific studies of the importance of the nutrition of all the health and sanitary health during the pregnancy that can impact the health and the potential of the calves, that this part is really, really important. So what we do, we take care of management, we monitor the fetal well-being. For the calving monitoring, we are also organized now. We are using the latest technologies like cameras, of course, but other devices that are connected to the internet and our systems. We have a very dedicated team, and that's probably the most important in our program. There is veterinary assistance all the time during the calving period, and if we feel something goes wrong, we will go directly to C-section. There is no waste of time, and that's quite an advantage. Then we don't go as far as Brian presented with his very nice bull campus. I really love the expression. Usually they are usually the calf lives between 30 and 60 days, but the health monitoring is really important, the biosecurity too, the growth monitoring, and so the feeding is extremely important, and as Brian presented, we can see the consequences a few months after when the bulls enter the AI center, but it starts from birth. So, at the conclusion, what we what's new and what we're doing at Boviteq. We have a fully integrated IVF platform with embryo freezing, with advanced semen analysis, which allow us to use the bull at their full potential. The OPU at satellite site is coming soon. The sex semen is very broad used for IVF, and the embryo genomics, we have developed the technology to have the analysis from the embryo. So my presentation is finished. I would like to thank my directors, Dr. Bélanger, Dr. Patrick Blandin, which is a research director, Dr. Christian Vigneault, which is our embryologist, and who is selecting all the embryo, and this evaluation is particularly important for decide which embryo we are able to freeze, which embryo we are able to biopsy. Dr. Remia, who is in charge of the recipients management, and all our technicians. Thank you for your attention, and I will be happy to answer any questions.
Thank you, Dr. Grant. Questions?
I just want to know if you have much of a pregnancy rate decrease on the biopsied embryos.
No. So the question was if the pregnancy rate decreased on the biopsied embryos that have been transferred. The answer is no. Is very comparable pregnancy rates. And the reason for that is probably because of the selection of the embryos. We are not able to biopsy every embryo. It has to be within certain standards of quality, and part of this job is done by our embryologist, and with this philosophy we have good success with these embryos.
Chris?
Is there any science that supports the suggestion that the genomics of the recipient is affecting the genomics of the embryo, the resulting animal?
So the question is there any scientific evidence that the genomic of the recipients can affect the genomic of the calf? I would say no. You mean, is the question only about the genomic, or?
Yeah, the vessel that the embryo is in, that the genomics of that animal,
Yeah.
can it have an effect on the genomics of the resulting calf?
I hope not. Not because ours are in Angus.
It's a really good question, I think, and there have been lots of research about that, mostly in humans, because embryo, well, all around, there are lots of embryo technologies in humans too, and the answer so far with just embryo transfer, the genomic of the recipients does not affect the genomic of the calf, and there is probably more research needed in that, but so far it has not been demonstrated.
Well, I work with a really bright young vet. I don't know where he gets his information. He suggested there is a correlation between the recipient and the calf.
It's a very good point, actually, but then it's really hard to separate the exact effect of the recipients from the effect of the management, I mean, from the nutrition and things like that. And so far, such a well-designed study has not been made, and there are some suggestions, like you said, but there is no scientific proof beyond that so far.
So on IVF embryos, in the one slide it showed that the implantable embryo still isn't quite the same quality as of a conventional flush. Am I right? Like they looked a little different?
You mean the embryo looks different, or the pregnancy rate?
No, the actual embryo,
Okay.
the inside of the embryo still looked a little different.
So the question is,
Well, I'm not finished. So if that's true, has there been any studies done on resulting calves from IVF as to a higher incidence of any genomic or genetic defects? Say, for instance, fertility rating on females resulting from IVF flushes as opposed to conventional flush or a natural birth. And I was going to ask Brian the same thing. If there's been any evidence of bulls resulting, young sires resulting from IVF as opposed to conventional, if there's been any difference in semen quality or fertility rating on some of those bulls. Or do you, has there been anything?
So the question was, does IVF have an effect of the reproductive potential, well, of the genetic defect and the reproductive potential of the offspring, male and female? So far, there has not been such an association between the potential of the offspring and the reproductive technology used. It's a very interesting question, and I think we should look at that. Then concerning the genetic defects, when IVF started in the late 80s and with these old protocols, which used different components, yes, there were some defects, and the most famous, well, the most well-known defect of that was the large calf syndrome. It has been observed the same in humans. And basically, when IVF started in the cow, it was the same techniques as in humans. And that's why I wanted to present this slide. So the last 10 years, we have been working a lot on the culture media because it has been from the human side. They have showed that most of these problems were caused by the culture media that were used. And so we have been working a lot to change this culture media, and now with our live calf program, we can follow exactly all these defects in that, and we do not observe genetical defects so far. So we have been calving 100 calves since the beginning, and we did not observe that. So I think that, yes, your question is very good. It's actually related to the technology, and it really depends on which culture media are used. And so from the breeder side, it can change from one company to another. And so far at Boviteq, we have not been observed that. Then your other question was about the difference between the conventional embryo and the IVF embryo.
Well, that part of the question was only to lead into the
Okay.
other and see if that was the cause of it, and so, but also, so you're only keeping these calves till they're 30 or 60 days old. So, is there any follow-up on the as they get older and when those heifers start to get bred? So I'm speaking from somewhat personal experience and only from hearsay that there has been some problems getting heifers pregnant that were a result of an IVF flush, and I don't know if that's common or if you've heard more of that, or
I did not. So the question is, if you have a heifer that is born from an IVF embryo, is she more likely to have reproductive problems and infertility problems? So far, we have not been observing that. I haven't heard about that from our company or from other companies in IVF. But they are lots of study about that, relating the nutrition and the health status of the dam between the pregnancy with the follicular response and the follicular population. Like some cow that are sick during the pregnancy are more likely to have daughters with lower potential, lower response potential. So that's all that has been done so far.
Maybe just one or two more questions, and then we'll have to Ron first.
Can you tell us what the approximate cost would be for one of those calves to be delivered back to my farm at, what, 60 days of age or whatever, that's been, the embryo has been genomically tested, sort of the gold standard, if you will? What
Yes.
would be that cost?
Yes, so there are several costs. The cost of the calf is currently around $3,500, and then there are the fees for the IVF process, which depends on how many embryos are produced with each cycle, but it will be about another $2,000. But usually, you don't have only one calf with, I mean, this IVF fees will be shared between maybe 3 to 8 calves.
Maybe one more question, Ed?
Just a question about when you do biopsies on the embryos, if you implant your higher end ones, are the others eligible to be frozen, or do they have to be implanted fresh as well?
The question is, so if we have a batch of embryos produced from one donor, and if we have biopsied only a few embryos, what can we do with the other embryos? Only transfer them or freeze them? My answer is it depends on what the embryo looks like. Most of the time, well, for the biopsy, it has to be the best embryo. So most of the time, you will be able to have some embryo biopsied, maybe a few other frozen, and some other transferred. But it's really hard to predict and to tell without seeing the embryos. It will vary a lot from one cow to another.
I think the question was, can you freeze a biopsied embryo? I don't.
Yeah. Sorry, I misunderstood. So we can freeze a conventional biopsied embryo for now. We are doing research about freezing biopsied IVF embryos with quite promising results, but for now it's not available on a commercial basis. It should be during 2013.
Thank you, Dr. Grand, and now we know why he has all the scientific degrees. At this time, it will have lunch. We'll break for lunch and then be back for about 1:45 or so to get the afternoon program started. So at this time, let's have lunch.